Before we delve into the intricate science behind atomic bombs, let's take a moment to understand their historical context. The journey began in the early 20th century, marked by groundbreaking discoveries in nuclear physics. In 1938, German scientists Otto Hahn and Fritz Strassmann discovered nuclear fission, a process that releases vast amounts of energy. This discovery set the stage for the development of nuclear weapons. Fast forward to World War II, the race to create the first atomic bomb was on. The United States initiated the Manhattan Project in 1942, a top-secret endeavor that brought together the brightest minds in physics and engineering. By July 16, 1945, the first successful test of an atomic bomb, known as Trinity, was conducted in the deserts of New Mexico. This marked a pivotal moment in human history, demonstrating the devastating power of nuclear energy. With this historical backdrop, let's now explore the science behind these formidable weapons. I've always been fascinated by the power of science, even when it leads to something as destructive as atomic bombs. At its core, an atomic bomb harnesses the energy released from nuclear fission. That's when you split heavy atoms like uranium or plutonium. Now, here's the cool part. When you split one of these atoms, it releases a ton of energy and more neutrons, which then go on to split more atoms. You know, it's pretty wild when you think about it. You need what's called a critical mass to keep this chain reaction going. That's the minimum amount of fissile material needed to sustain the reaction. In a bomb, they actually compress this material into a supercritical mass, which is when things get really intense. The chain reaction goes out of control and boom, you've got an atomic explosion. So, what's really going on here with the actual bomb designs? The two most famous atomic bombs, Little Boy and Fat Man, use different methods to achieve that supercritical mass. Little Boy used a gun-type design, basically shooting one piece of uranium into another. Pretty straightforward, right? Fat Man, on the other hand, used an implosion design, compressing a plutonium core with conventional explosives. When these bombs detonate, they release energy in multiple forms: intense heat, a powerful shockwave, and deadly radiation. It's a sobering reminder of the immense power contained within atoms, and it really makes you think about the responsibility that comes with scientific knowledge.